Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is continuation to the certain point. It's about the block, a pulley, that's hanging like that. And we have two masses, M1 and M2. The previous problem we were pulling it along the horizontal line. Here it is M1 and M2, and of course the M1 is given, M2 is given, they want acceleration. Very nice. Alright, so the first thing is a picture, it's already here. The second picture is forces. This force is down and it is M1G. And this is gravity, and this mass is communicating, interacting with the Earth, so it's M1G. Another force that is T, is tension. And the fact that the rope is like that, it doesn't matter, we can always put it like that, and tension against the rope is the same. Tension against the rope is the same, so the same T would be acting here on this rope. Nothing changes. The fact that tension is the same is a result of the fact that rope is weightless. There is no weight, no mass in the rope. Of course it's not possible, but when they say so, that means it's incomparably smaller than masses, all other masses that are here. And another thing with the pulleys is that there is no friction. If there is a friction in the pulley, imagine there is other forces that prevent pulley to go, to rotate. There's always friction there, but let's say we have a very high quality pulley and it's very smooth and no friction, and friction that is there is comparably less than M1Gs and M2Gs and tension. So no weight, no mass, no friction, and of course this rope is non-elastic. That means acceleration of this body and this body would be the same. We don't know which way, so I put it A, let's keep it like that. And so there are no more forces here, and of course here there are also two forces, M2 and G. Okay, and we have to write this second law of motion. It's equal ma, and we can write the second law of Newton's law for the first body. And this, of course, acceleration would be the same, and we can write it for the second body. And second body it would be the same, only m2, right? So this is generic, this is first body, this is second body. So the only difference is M2. So now let's expand. Let's say that we have first body T, this vector, plus M1G vector equal M1A vector. And of course we can say, let's, for the first body, put the X here. It's my right to direct it anywhere I want. So it would be T up, M1G down. Acceleration I don't know, so let's assume it's going up. And for the second body, I can use the same X, so I can use the X directed down. It doesn't matter. Let's use the same, so it would be like the same X for the second body. So for the second body, it would be this tangent vector plus M2G vector, right, equal M2A vector. And if I do it in projections, and I do projections against the same axis, I can, for this body, I can put X down, but I am just lazy, I put it in the same way. So T again would be positive, right? Minus M2G would be the same. The only thing that's very important, if I assume that acceleration here goes here, then for this body acceleration is go down. So if acceleration here, then it would be minus m2a. And this is my two equations that I have that I can write here together. T1 minus m1g equal m1a, and T. And for the second, T minus m2g equal minus m2a. So basically, this minus because acceleration is directed down. If I would write for this body, this x I will direct down, then t would be negative, m2g would be positive, and acceleration will be down the same way, so it will be positive. So it's exactly like we'll change all the names on the opposite, so it's all good. So now if this is the case, I have t unknown and I have a unknown. And let's solve this. For example, let's subtract, because I want to get rid of t. That's the easiest way. Let's subtract this, so left-right would become t minus m1g, and I am subtracting, so minus t plus m2g, right? I'm subtracting, so I'm changing the names, and I'm subtracting on purpose because t would be gone. And here I'm subtracting, I have m1a plus m2a, because when I'm subtracting, minus minus is gone. So I subtract left side and I subtract right side, and there is no t. So I have m2 minus m1 g, I factor g out, equals, I factor a out, m1 plus m2, and I have a equals m2 minus m1 divided over m1 plus m2g. And if you think about it, it's exactly like previous problem, because what's on top? On top is m2g minus m1g. And if you remember, there was f2 minus f1, and in reality this is force that moving one way, and this is force that moving another way. And so the net is the difference between those, and this is the force that pulling. And the force that pulling it accelerates the whole system, consisting of two masses. And so it's exactly this force, the total force, equals acceleration of the total mass. And total mass is this. And so this is the same formula as before, only there was F2 and F1, and here F2, M2G and M1G. And again, we have A is positive. A is positive, that means M2 minus M1 is positive, and that means M1 is less than M2. And of course, if this mass is bigger than this, it goes that way, and acceleration really becomes positive. So we guessed right. But if M1 is bigger than acceleration becomes negative, and all the signs here change, then that means M1 is heavier than M2, and M1 pushes more, and the system starts to go down. So simple block, but the same thing. And of course, if M1 and M2 equal 0, then acceleration is 0. We have two equal masses sitting on the block, and everything is fine. And of course, if we know A, we can obtain T. Let's wipe it out, and we can obtain T tangent. And we're very similar to what we have in the previous case, in the previous program, M1A. This is the formula. We're plugging A. We have T equal M1G plus M1, and instead of A, we're plugging M2, and I will already open the brackets, M2G minus M1G, and here would be M1 plus M2, and I come to common denominator, which will be m1 plus m2, and I have m1 plus m2 multiplied by this m1g, and then I will have this m1 multiplied by m2g minus m1g, right? And then all I have to do is open brackets, and half of them will be gone. So m1 by m1, it would be m1 squared g plus m2 m1 g plus m2, this is m1, so it would be m1 by m12 g, and this would be minus m1. I will remove this because I am out of space. So it would be m1 squared g, and here would be m1 plus m2, and those two would be gone, and those two would be 2. So t would become 2 m1 m2, very symmetrical result, as it should be, m1 plus m2. So the tangent again would be in between m1g and m2g. The tangent here, if this is all going that way, would be bigger than m1g, but the tangent here would be less than m2g, but t would be positive. In this case, we obviously see immediately that t is always positive, no matter what, because this is the scenario when the forces are directed in opposite direction. Remember, we have all this fuss with t in previous problem when we were trying to draw like this, and then this was a rope, and then we were helping in the same direction. So if we help too much and this started accelerating too fast, this rope would be limp and t become negative. T cannot be negative. T tension of the rope is always positive, and this is obviously the case here. Alright? So I hope that clears it all up. And if you liked it, like. If you haven't subscribed, subscribe. If you want a question, don't be shy and put it in the comment section. Thank you very much.